Use the 68%, 95%, 99.7% rule to answer each of the following. Now remember what this refers to. So 68 is within plus or minus 1 standard deviations from the mean, plus or minus 2 for 95, and plus or minus 3 for 99.7. So we're given a random variable z. It's normally distributed with a mean of 0 and a standard deviation of 1. So between -3 and 3 is 3 standard deviations either side of the mean. So that's going to be 99.7%, which is a probability of 0.997. Of course, you could give it as a percentage, there's not a problem there. Now for z greater than -2, so -2 is here, we're just talking about greater than. Now this area here is 50% because of the symmetry of the normal distribution. Between plus or minus 2 is 95%, so this bit here must be a half of that because of the symmetry. So it's a half of 95, which is 47.5%. So here we're going to have 0.5 added to 0.475, which is 0.975. So the heights of a group of 300 adults are found to be normally distributed with a mean of 1.7 and a standard deviation of 0.12. Determine the approximate percentage of adults from this group with a height less than 1.82 meters. So the mean is 1.7. 1.82 is 1 standard deviation above. So we want heights less than that. So we want all of these people, and that's 50%. And this bit here must be half of 68%, so 34%. So that looks like it's just going to be 84%. How many of the adults would you expect to have a height greater than 1.82 meters? So a height greater than must be 16% if less than was 84%. So we want 16% of the 300 adults. Well, if we think about it, 16% of 100 is equal to 16. So 16% of 300 would be 3/16, giving us 48.